Hello everyone, I am Paguni, your chemistry SME. So let's move forward with today's topic. In the first question, we have to match the column and we have to find the oxidation number of the underlined elements. So in the first we'll see Na2O2. In this, the underlined element here is oxygen. Therefore, the unknown oxidation number we'll take it as X. And then what we'll do is we know that the oxidation number of sodium atoms is plus 1. Alright, and we'll multiply it by 2 because 2 sodium atoms are there. Therefore, plus 1 plus because 2 oxygen atoms are there. Therefore, again we'll multiply by 2 into x, that is the unknown. And we equate it to 0. For a molecule, it will always be equal to 0. If it is ionic species, then it will be equal to the charge it carries. Alright, so upon solving this, we see that x equals to minus 1. In the other Q, we have NH3. In this, the underlined element is N. Alright, so X will be N and plus 3 because number of atoms of hydrogen are 3. And then the oxidation number of hydrogen will be equal to 0 and then X would be equals to minus 3. Okay, next in our column, we have SO2. So in SO2, the underlying element is S, which will be considered as X. So X plus 2, because 2 atoms are there, into minus 2, that is the oxidation number of oxygen, will be equated to 0. Upon solving this and rearranging, we get X to be plus 4. Alright, so it would be plus 4. And in last S, we have CH4, underlying element being C atom. So it will be considered as X. If plus 4 into plus 1 equals to 0. Therefore, we have x plus 4 equals to 0. And we'll have is x equals to minus 4. Upon matching all these with column B, the final answer will come out to be 3. Okay. Now, in the next question, we have the sum of oxidation state of terminal carbon. Terminal carbon is required. In C3O2, that is carbon suboxide. What is the structure of C3O2 first? So its structure is like this, which is the terminal atom. The terminal atom is oxygen, but we need to find the oxidation state of terminal carbon atom, which is this. Alright, this and this. And C, in question, notice the following thing, oxidation state. Therefore, sum of this oxidation state and sum of this. We need this. So let's see what is the oxidation state. Now it is connected to two bonds of oxygen, double bond oxygen. All right. So if we see by this method, that upon breaking it, see here one and one. If we get minus one, what it will have, because oxygen is more electronegative, so it will take the electron and it would have plus one and plus one. And similar would be the case in this. Therefore, it would be plus 2, it would be minus 2. And what would be the sum? 2 plus 2, that is 4. Alright. So, the answer would be 4. See, why we do not break it here? Because in this case, here. Alright. So, it is connected to the same atom, that is carbon. So, will not have it will have zero oxidation state in that side. But in with respect to oxygen, it is more electronegative. That is why it will have oxidation state. So let's move on with the next question. This is the answer. So in the next question, we'll see for the which of the following reaction products are incorrect. Okay, we need to find Which chemical reaction gives incorrect products here? In this, see, in the first reaction, it is simply Cu plus H2SO4 to give CuSO4. So in this, you can see that displacement is there. CuSO4 is coming and attaching to Cu is coming and attaching to CuSO4. All right. Similar is the case of uh, concentrated nitric acid when it is taken in place of sulfuric acid. We are getting copper nitrate. And for reaction 3, we'll see that K2SO4, it is also correct. But what the problem in reaction 4 is that the product is totally wrong. All right. Because when Mn2 plus will react with S2O8 to 2 negative, I'll just change the color. So when Mn2 plus will react with S2O8 2 negative, then see this S2O8 2 negative will be reduced to SO4 2 negative. Alright, and Mn2 plus would be oxidized to Mn3 plus. Am I clear? So therefore this reaction here is wrong. So this is the incorrect product. In the next question, 54, KMNO4 can be prepared from K2MNO4 as per the reaction. This is the reaction given to us, and the reaction can go to completion by removing OH ions or by adding. See, in this, we'll see that whenever we have to shift the equilibrium to the right hand side, that is to the product side, or we can say that when we want the reaction to move towards completion, we either add reactants or we remove the products. All right. Therefore, we'll see that HCl and SO2 here, HCl and SO2. These are the reducing agents. Therefore, they will increase the amount of MnO4 negative. They will convert MnO4 to negative to MnO4 negative. Sorry. No. They will reduce MnO4 negative. That is, the equilibrium will shift in the opposite direction. All right. So that is why we cannot add those. And now we add KOH ions and it will give OH ions, and there is no meaning of adding that because we are already removing that to increase the product, to increase our equilibrium towards product side. Therefore, it is of no use. Therefore, CO2 being neutral will have no effect. So we can use it to move the equilibrium in the forward direction. So it won't be the correct answer. The correct answer would be CO2. And see, what you can make out from this reaction is that when CO2 is added, which ion removal is even more felicitated. Okay. Therefore, it will it will become carbonate ion and H2O. Therefore, our reaction will be moving forward in the forward direction. In the next question, what is the oxidation number of the central bromine atom in Br3O8? I guess it's clear now. What is the oxidation number of central bromine atom in Br3O8? See, this is the structure of Br3O8, and the central bromine atom oxidation state is ours. That is this one. All right, so we'll consider it as X, and we'll see. See, we can do this using two methods. As I told you earlier, by breaking the bonds, Here it will get the plus 2, and from here also it will get plus 2. And this is 0 because it is the same atom. Therefore, the final oxidation state will be plus 4. Okay, or you can do it by considering X bromine plus 2, because two oxygen atoms are there, this and this, and their charge equals to 0. That is, it will give plus 4. So this is the correct answer. In the next question, which of the following is a displacement redox reaction? So what happens in a displacement reaction? One atom is displaced by the other atom in the reactant. So we see in option A, this is an example of combustion reaction. All right, and in this, decomposition of NH is taking place. Therefore, it uh, it can be example of decomposition reaction. Now in this, you'll see that Cr is being replaced by Al. Therefore, yes, it is an example of displacement reaction. And in V2O5, calcium replaces V, that is vanadium. That is, it is also an example of displacement reaction. Let's see. And it also needs to be redox. Therefore, you see that in V2O5, oxidation state changes from plus 5 to 0. That is, here it is reducing. Alright, and for calcium, you'll see from 0 to plus 2. It is getting increased, it's oxidizing. In the next one, you'll see that from Cr plus 3 to Cr0, it is getting reduced. And here it is getting oxidized. Alright. And what is a redox reaction in which one gets oxidized and other species gets reduced? Therefore, the correct answer would be C and D, that is option 3. In the next question, again we have to match the column 1 and 2. Therefore, now you can easily make out this is an example of combustion reaction. Alright. And or if combustion reaction is not given, then what is being done here? See, oxygen is combining with CH4 and giving CO2. So it is also an example of combination reaction because two or more substances combine to form a single product. Okay, so it is an example of combination reaction. Then in Fe plus 3H2O, you can see Fe is displacing here and becoming Fe2O3. Therefore, this is an example of displacement reaction. This is an example of displacement reaction. Here, H2O is giving H2 plus O2. It's breaking into its substituents, atoms, or molecules. Therefore, it is an example of decomposition reaction. Now, in S8, in D, that is S8 is becoming S2 minus and S2O3. It is an example of disproportionation reaction. Let's see what is a disproportionation reaction. In this, one moiety undergoes oxidation as well as reduction in the same chemical reaction simultaneously. Alright? So, which is the correct option? The correct option is first. A S B R C P and D Q. Yeah. Okay, so this is the correct answer. In the next question, we'll see in which reaction it is indicated the oxidizing behavior of H2SO4. C. Um, the oxidizing behavior should be shown. That is, if it should oxidize the species, the oxidation state should increase. Okay, but in these reactions, in this reaction, in this reaction, in this reaction, it is same. Okay, so but in this reaction, you'll see that it is -1 and it is 0. Therefore, it is oxidizing. In all the other reaction, there is no change. See here, it is PCl5. Therefore, if we see the oxidation state of P, it would be X plus minus 5 equals to 0. It would be plus 5. Here also it is plus 5. Why? Because X minus 2 minus 3. It would equals to 0. It would be plus 5. Alright, it is plus 5 here. It is here the oxidation state of Na would be X minus 2 plus 1, that is equals to 0. Therefore, X equals to plus 1. Here also 2x plus 6 minus 8 equals to 0. Because why 8? 4 into minus 2. Therefore, what will it give? X equals to plus 1. Therefore, it is also same. And similarly, here it is plus 1 and here also it is plus 1. So, only the option 4 is correct option. In the next question, which of the following transition elements possess the highest number of oxidation states? See, it is a very much known fact that in the 3D series, that is scandium, titanium, vanadium, chromium, manganese, this series, the highest number of oxidation state is of manganese. And why? Because initially the number of unpaired electron increases till Mn, but after Mn it decreases. The number of unpaired electrons decreases. Therefore, these are the oxidation states that are possible in the elements, which can have only plus 3. Whereas Cr can range from plus 2 to plus 6. But the maximum is in manganese. That is why it would be the answer. The next question, which of the following has the least tendency in plus 3 oxidation state to show disproportionation reaction? Okay, see. Um, in disproportionation reaction, I have already told you what it is about. One species should undergo oxidation as well as reduction simultaneously. All right. Therefore, these are the elements of nitrogen family. And on moving down the group, what happens? Inert pair effect is shown. Now, what is inert pair effect? The inertness of s orbitals to participate in the bonding. That is why the higher oxidation state are less favorable because s orbitals do not participate. S orbital electrons do not participate in the bonding, therefore, which are shown lower oxidation states. All right. Therefore, the element which is below in this group is Bi. All right. That is bismuth. So it would be the correct answer. Both bismuth and Sb are down. Therefore, it won't show much disproportionation. But the element which is even more resistant to show disproportionation reaction is bismuth because it comes even below Sb. So now in the next question, it is given that consider the reactions. These are the reactions given to us. In these reactions, which of the following is correct for H2O2? See, there are few things you need to know about H2O2. And what are those? In H2O2, the oxidation state of O is -1. It is a peroxide, all right? And H2O2 is reducing agent as well as an oxidizing agent. It depends upon the reaction. All right. Now let's see. In H2O2 and HI, this is the reaction given. Now here oxidation is taking place because It is converting from +1 to 0, or -1 to 0. Alright, and in the next reaction, you will see the oxidation state of chlorine changes from +1 to -1, which is the reduction. So, therefore, oxidation in first reaction, it acts as oxidizing agent in reaction 1 and reducing agent in reaction 2. Therefore, option 3 would be the correct answer. In the next question, in the reaction given below, identify the species undergoing redox reaction. One should undergo oxidation and the other species should undergo reduction. Okay, so here this reaction is given 2Na plus H2 to give 2Na. Alright, so we can find here that here it is 0 and here it is +1. And it is undergoing oxidation. All right, it is oxidized. In hydrogen, it is in molecular form, therefore it is 0. And now, when it becomes NaH, it has become a hydride. Therefore, its oxidation state will be -1. So, it is getting reduced. Therefore, this is also correct, this is also correct. That is, statement 4 is correct. Both 2 and 3. In the next question, in which of the following reactions there is no change in valency? Or we can say there is no change in oxidation number. In this, see, here in KClO3, it is -1, but here it is x -6 equals to 0, +5. It is +5. That is, here there is a change. In next, you will see it is 0, but it is -2. Therefore, here also changes there. Here also change. Here also it changes. Alright, in this BaO2 and H2SO4, we'll see BaSO4 is formed. The oxidation state of Ba here is +2. We can see here it is +2 and it is oxygen is -1. Here also it remains +2. Sulfur also remains same, +6 and +6, and hydrogen also remains same. Every element's oxidation state remains the same. -2 for oxygen here, and here it is peroxide case, so therefore it is -1. Therefore, this is the correct option C. Because here also it is changing. You see, here it is 0. Here it would be -1 because it is barium peroxide. So this in this case also it changes. Therefore, option C is the correct answer. In question number 64, assertion is given to us in a reaction Zn plus CuSO4 to give ZnSO4 plus Cu. Zn is a reductant but itself gets oxidized. Okay. And what is given in reason in a redox reaction, oxidant is reduced by accepting electrons. Reductant is oxidized by losing electrons. Okay, let's see if assertion is correct or not. This is the chemical reaction that is given to us, where you can see that it is 0 and it is +2. Therefore, oxidation is taking place for Zn. And for Cu, you see it is 0 and it is +2. Therefore, reduction takes place. Therefore, Zn will act as a reductant. It oxidizes itself, whereas it reduces the other species. Therefore, assertion is correct. Now, the reason in a redox reaction, yes, it is a redox reaction. Oxidant is reduced by accepting electrons. Yes, the oxidant is getting reduced itself. It oxidizes the other species, whereas vice versa is true for reductant. Therefore, reason is also correct, and this is the correct explanation of the assertion. Therefore, option A is the correct answer. In the next question, we have to again match the columns. See, this one is easy. You'll see Mg plus O2 to give Mg, which is correct here. You see no role of hydrogen, no role of electron for yes. Addition of oxygen. Therefore, A with R, which option is correct out of these two? That is the possibility of this two is there. Then in the next reaction, Mg plus Cl2 to give MgCl2. Now you can see that addition of chlorine is there. And which statement would be correct according to this one? Therefore, B will match with S. Now you'll see that this is wrong because in this B matches with P. Therefore, this is our correct answer. But let's see the other options as well. H2S plus O2 to give 2S plus H2O. Now you'll see that this reaction involves magnesium reacting with chlorine. This is the above one. In this H2S plus O2, this hydrogen atoms, you'll see that sulfur, it was -2 before and now it is 0. Alright. So hydrogen atoms are losing electrons. That is, they are getting oxidized because oxygen is added to hydrogen. So obviously they'll be oxidized. So therefore, C will match with P. That is removal of hydrogen. And B will match with Q because Ki in this potassium is an electropositive element which will form compound with water and oxygen. Its elemental form will no more be elemental. Therefore, this is the correct option. So the next question, the number of electrons involved in the reduction of one nitrate ion to hydrogen. What is a nitrate ion? NO3 minus. What is hydrogen? N2H4. Okay. So let's see. This is the reaction, and what is the oxidation state of nitrogen here? X plus 3 minus 2 equals to -1, that is x equals to +5. And in N2H4, that is in case of NO3 minus. In N2H4, it would be -2, 2x minus plus there, the hydrogen is +4 equals to 0. Okay, so this will be -2. So here it is -2, here it would be +5. So you'll see that change of electron from +5 to -2 is there. See, we can just count it in a mathematical way because what is happening is +5, it is reducing. So, and becoming -2, what is the change from -2? -1, 0, 1, 2, 3, 4, and 5. Therefore, 7 electron changes there. Or we can see it by balancing the following chemical equation. How we will balance it? You see that in this case only two nitrogen atoms are there, and in this case one. Therefore, we'll put 2 here, and to compensate for oxygen, we'll be adding H2O. So why we here we will add 6H2? Why? Because 3 into 2, 6 uh, 6 atoms of oxygen are there. Therefore, 6H2O will be added. Now we'll have to balance the number of hydrogen. How many hydrogen are there? 6 into 2, 12 plus 4. How many? 16. Therefore, 16H plus will be added. And to compensate and to maintain the neutrality, we'll be adding 14 electrons here. Okay. So, and okay, why 14 electrons? I'll tell you that also. See, 16H plus, so positive ions are already there. 16 and 2 into negative charge. That is 14 positive charges there. Therefore, to compensate that, to neutralize it, we'll be adding 14 electrons. Therefore, if two nitrate ions require 14 electrons, then one nitrate ion will require, obviously, 14 by 7, that is 14 by 2, that is 7 electrons. Alright. So, correct answer would be 7. Next question, we'll see that oxidation number of chromium in potassium dichromate. This is severely easy. K2, Cr2, O7. Here, let's consider it as X. Therefore, Uh, 2 into plus 1 plus 2x plus 7 into minus 2 equals to 0. Therefore, 2 plus 2x minus 14 will give you 0. And x would be 12 by 2, that is 6. So this is the correct answer. In the next question, the average oxidation state of sulfur. See, average oxidation state I asked. In Na2S4O6. So, see, uh, how we will calculate this? Na2S4O6 is there. Therefore, 2 plus 4x minus 12 equals to 0. Why 12? 6 into 2. Minus 2. 6 into minus 2. That is why minus 12 will come. Therefore, it would be x equals to 10 by 4. That is 2.5. Okay. So, see, initially I told you that uh, the charge, whatever charge a species will be carrying, it will be equal to the final charge when we calculate the oxidation state. So here we are showing that. See, Na here, sodium here acts as a counter ion. Okay. Therefore, this species can also be written as Na plus 2 or S4O6 2 minus. That is why here we can take this. And the whole charge 4x minus 12 will equal to minus 2 because minus 2 is the charge here. And then using simple mathematics, we'll find the answer to the 2.5. Now in the next question, we'll see which one of the following reaction involves disproportionation. As I told you earlier that in a disproportionation reaction, one species will undergo oxidation as well as reduction simultaneously. So you'll see that uh, in this, so displacement was there here also. In this case, you see that from 0, it goes to minus 1 as well as plus 1. Therefore, this is the disproportionation reaction. In the next question, the oxidation number of an element in a compound is evaluated on the basis of certain rules. Which of the following is incorrect? You'll have to tell which of the following is incorrect rule. The oxidation number of hydrogen is always plus 1. No, this is totally wrong. This is the answer. Why? Because oxidation number of hydrogen can be 0. For example, in H2, the oxidation number of uh, hydrogen is 0. In hydrides, it is minus 1. For example, in NaH, we saw earlier, it is, for hydrogen, it is minus 1. Therefore, this is the incorrect statement. Okay. So, and why? See, all the other statements are in fact correct. Why? Because we have always seen while finding the oxidation number, we always put the algebraic sum of all the oxidation number in a compound to be 0. And we have always taken the element in the free or uncombined oxidation state to be 0. For example, in H2, as I told, it is 0. And fluorine being the most electronegative element is always minus 1. It is always minus 1. It is never positive for any other number. So in the next question, which of the following explanations is incorrect for ClO4 minus species? See, in ClO4, let's find out what is the oxidation state of ClO4. Okay, so X plus 4 into minus 2 equals to minus 1. That is 4 minus x minus 6 equals to x minus 8 equals to minus 1. X would be plus 7. See, it is in the maximum oxidation state. Therefore, it cannot be oxidized further. It can only be reduced. Therefore, it cannot show disproportionation reaction. Okay. This is an incorrect statement that it is showing disproportionation. It cannot. All the other statements are correct. In the next question, the reaction of white phosphorus with aqueous NaOH gives phosphine along with another phosphorus containing compound. The reaction is, so let's see which reaction is this. It is this reaction in which you'll see that the oxidation change of P4 is from 0 to -3 as well as +1. Therefore, here oxidation takes place and here reduction is taking place. Therefore, it is a disproportionation reaction. In the next question, which of the following halogen does not undergo disproportionation reaction? As I already mentioned earlier, that chlorine is the most electronegative element. It cannot undergo any oxidation. Alright. In the next question, consider the following decomposition reaction. This is the reaction given to us. In the above reaction, we have to see what is happening in this reaction. So, see, KClO3 to give 2 KCl plus 3O2. Here, the oxidation state is +1, it is +5, and it is -2. Here it is +1 and -1, and here it is 0. Now you see that the oxidation state of uh, potassium is not changing, it is +1. Therefore, it is not undergoing neither reduction or oxidation. And the oxidation state of chlorine changes. It is undergoing reduction. Chlorine is undergoing reduction. Okay, so it changes from +5 to -1. Therefore, it undergoes reduction. And in case of oxygen, it increases from -2 to 0. Therefore, obviously, it is undergoing oxidation. Okay, so option 2 would be correct here only because it is chlorine is undergoing reduction. Potassium is same, oxygen is being reduced. So this is the correct option. In the next question, in which of the following reactions the underlined substance is oxidized? We have to tell which underlying substance is oxidized. Okay, so see in this reaction, here the oxidation state is 0, here it is -3. Therefore, it is reduced. Alright, in the next, we see it of Br from 0 to -1. Therefore, it is also reduced. In this next, the underlined element is Zn. From +2, it is going 0. Again, it is reduced. Therefore, obviously, the last option is the correct answer. Let's see how. Here it is +2 oxidation state, and here the carbon is on +4. Therefore, it is getting oxidized. Okay. So, answer 4 is the correct option. Let's see. In the next question, this is the kinetics question. In a first order reaction, the concentration of the reactant decreases from zero point 0.8 to zero point 0.4 in 15 minutes. That then the time taken for the concentration to change from zero point 0.1 to 0.025 molar. See, this is easy. How we'll solve it? If in zero point 0.8 to zero point 0.4 change, it is taking 15 minutes. That is, it is T half. It is reduced to half of its concentration. Now, for a change in zero point 0.1, the firstly it will go to this, and then it will go to this. Therefore, 2 half lives are required. Alright. And therefore, what would be the answer? Twice of 15 minutes, that is 30 minutes. So, therefore, this is the correct answer. In the next question, the decomposition of the substance follows first order kinetics. If its concentration is reduced to 1/8 of the initial value in 24 minutes. See, time is given to be 24 minutes. And let us consider A naught, the initial concentration, to be 1. And the final concentration would be 1 by 8. It is reduced to, that is, it has now become 1/8. Now let us put it in the formula for first order kinetics, which is this. K equals to 2.303 upon T log initial upon final concentration. And upon putting, we'll get this. Therefore, 8 will just go above and C would be the correct answer. In the next question, the constant for zero order reaction is 20 to 10 to the power -2 mole per liter per second. If the concentration of the reactant after 25 seconds is zero point 0.5 molar, the initial concentration must have been. See what for a zero order reaction, what is the formula we use? Kt equals to A naught minus A. Alright. So here you'll see it can be then rewritten as this. Therefore, we'll just substitute the values. We already have our all the values here. Concentration after 25 seconds. Therefore, 25 is the time. And 0.5 is the final concentration because it is given that concentration after this time is zero point 0.5. So our final would be 0.5 concentration. And therefore, just substituting on rearranging and calculating, we'll get the answer to be 1 molar. In the next question, half-lives of first order and a zero order reaction are the same. Then the ratio of initial and final rates. Then the ratio of initial rates of first, this is of initial rates of the first order reaction to that of zero order reaction. See what are the half-lives of first and zero order reaction. So for zero order reaction, it is A naught by 2K, and for first order reaction, it is 0.693 upon K. A naught is given to be 1. Okay. So for zero order reaction, it would be 1 upon 2K. Let us consider this to be K dash for the first order reaction, and this is given to be 0.693 K. 693 upon K dash. Therefore, just rearranging, we'll see that we have to find the ratio of first order to zero order. Okay, therefore K dash will go there. So K dash upon K equals to 0.693 into 2. Therefore, this would be our answer, that is option 2. In the next question, which of the following statements is incorrect? We have to tell the incorrect statement. A second order reaction must be bimolecular elementary reaction. See, this reaction is completely false. So this is our answer. Why? See, in a reaction, you see if A plus B can give product, this can also be a second order reaction. 2A 2 product can also be a second order reaction. Even if it is a complex reaction, it could be this. But so it is, this is also second order, this is also a second order. This is second order reaction, which is bimolecular elementary reaction. Okay, that is a single step reaction in biomolecular. This is that, but these are second order reaction without them being biomolecular elementary reactions. Okay, so this is the correct option. The other options, the biomolecular elementary reaction must be a second order reaction. You will see that a biomolecular reaction, as in the case of this. See, biomolecular elementary reaction. This is a bimolecular elementary reaction. And in an elementary reaction, the molecularity is equals to order. Okay. Molecularity of the reaction is equals to the order of the reaction. And here the molecularity is 2 and order of the reaction is also 2. Therefore, this statement is correct. In the next statement, zero order reaction must be a complex reaction. Yes, zero order reaction can be is a complex reaction. And the first order reaction may be complex or elementary reaction. These statement is also correct. But first order reaction may be complex or elementary. It can be one step or it may move forward in other step, in many steps. Okay, in the other question we see that consider the following statements. First, increase in concentration of reactants increases the rate of zero order reaction. This is incorrect. Why? Because rate constant of a zero order reaction does not depend upon concentration. Okay. Then in point two, rate constant K is equal to collision frequency A. E A is zero. That is activation energy is zero. Let's see this. In Arrhenius equation, that is K equals to A e to the power minus EA by RT. If we take e to be 0, then what it becomes? K equals to A e to the power 0. And anything to the power 0 is 1. Okay, so it would be equals to Ka. K equals to A. So it is the correct option. And rate constant K is equal to collision frequency A. PA is infinity. We have seen that it is not correct because it is equals to okay. And in the next, we'll see that ln K versus ln T is a straight line. And ln K, C. Now let's take ln on both sides of this equation. So it would become ln K equals to ln K minus EA by RT. Okay. So, ln K, this is the straight line equation y equals to mx plus c. Okay, so 1 upon t, here you can see this, and this is obviously a straight line. Therefore, this is the correct option. ln K versus 1 by t. Okay, and the slope is minus EA by R. M is minus EA by. Therefore, the correct option is second and fifth. Oh, sorry. In the next question, according to collision theory, which of the following is not a true statement considering a concerning a catalyst? See, what is a catalyst? It when we add the catalyst, it does not change the rate of the reaction. Okay. Uh, wait, a catalyst. It only changes the activation energy. It won't change the temperature. It will increase the rate of the reaction or it decrease the rate of the reaction. If the catalyst is positive, it will increase the rate of the reaction. If the catalyst is negative, it will decrease the rate of the reaction. Therefore, catalyst will never change the temperature of the reaction. It can only affect the rate, and the by it how it will affect the rate by influencing the number of collisions or by decreasing or increasing the activation energy. It generally decreases the activation energy. It will never change the equilibrium temperature. Therefore, option B is not a true statement. Option 1 is not a true statement. In question number 83, we'll see in a reaction the threshold energy is equal to C. Active in all the options we can see activation energy is being used. So what is activation energy? So this here you see the diagram. It is the activation energy. That is the minimum energy in potential energy of a system that is required for the molecules to react. If they do not have the activation energy, the molecules will not form the products. They will not form an intermediate and won't form the products then. So, and a threshold energy, it is what? It is the minimum kinetic energy required to convert kinetic energy into activation energy during the formation of activated complex. So, here we'll have the activated complex. So, here we'll have threshold energy. This much, whatever energy, it is the average internal energy, and this is the activation energy. Okay, so average internal energy is also the normal energy of the reactant. So threshold energy will be the sum of these two. Therefore, explanation 1 would be the correct answer. In the next question, a chemical reaction was carried out at 300 Kelvin and 280 Kelvin. The rate constants were found to be K1 and K2. Then, I guess this question is incomplete. Yeah, so see, this after this, what they are doing is, they are asking that, read out this. No, no, see, what we have to do is we have to tell the nature of K1 and K2 on these two temperature, like two temperatures are given to us, and K1 and K2 at these temperatures, K1 is given and one K2 is given. Therefore, we have to find the relation between them. Okay, so you can do like so. We know that for every 10-degree increase in temperature, the rate constant will be doubled. Okay, for 10-degree change, the rate constant is two times. So here you see the temperature difference of 20 degrees. Okay, so it would be for 20 degrees, it would be four times. So the rate constant for 20 degrees would be four times. That is, our K1 would be 4 of K2. Okay, because it is 20 degree more than K2. So, or we can say that K2 equals to 1 by 4 K1, that is 0.25 K2. 0.25 K1. K2 equals to 0.25 K1. This would be the correct answer. In the next question, for a certain reaction, the rate equals to K A2 B when the initial concentration of A is tripled, keeping the concentration of B constant, then the initial rate would be. So let us consider the rate initially to be R. Then when it is increased by, okay, so our concentration is tripled. It would be 3A now, and B is same. Okay, so what it will become 3 square, that is 9. So that we can take out as it is a constant, A square B. That is, it will become 9R. That is 9 times. In the next question, for the chemical reaction, N2 plus 3H2 give 2NH3, the correct option is. So we just have to write it in the differential form. See, this is very well known Haber's process to produce ammonia. So how can we write it? We can write it in this form, that is, every species of the reactant will have a negative sign since it is getting exhausted. And it will be written with respect to time and divided by the stoichiometric factor that it has. And the products will not have the negative sign because they are being formed. Therefore, this is the correct way to write it, and which corresponds to explanation B, to option B. Okay, because in this option 1 by 2 is missing. Here we have 1 by 2, and we don't multiply. And hydrogen, okay, so this would be the correct option. Here it will have a negative sign. In the next question, effective collisions are known to possess. See, what are the effective collisions in any reaction? So, whenever a reaction has to be proceeded, a collision will occur, then only products will form. For the collisions, the threshold energy should be, and breaking of the bonds, formation of the new bonds in products, and proper orientation should be there. Therefore, what are the options? That is A, B, C, and E. As I said, it should have energy greater than threshold energy, which is option A, breaking of old bonds. Option B, formation of new bonds in products. Option C, and proper orientation. It should always have proper orientation. Even if it has sufficient energy and do not have proper orientation, then the reaction won't proceed. We will not get the products. So option 2 is the correct option. And the next question, the time taken by the first order decomposition of SO2 Cl2 to decompose 40%. Okay, time is asked. Final concentration is given, that is A at time t. In is 5. Okay, time is already given. That is 560 seconds. Okay, and what is asked then? Rate constant is asked. So what formula we will use? We will be using K equals to 2.303 upon T log A naught by Gt. We'll substitute the values here. The final concentration, we'll let it to be 100 because 40% is the final. The initial concentration we'll be taking as 100 because the final concentration is 40. So upon just substituting the values, we'll get this answer, that is 1. In the next question, the activation energy of any chemical reaction can be calculated if one knows the value of. Okay, see, in our formula, that is our Arrhenius equation, K equals to AE to the power minus EA by RT. Then it will become ln K equals to ln K minus EA by RT. Okay, then see, what is required is at so two different, if we take ln scale at two different temperatures, then we'll have K1 and K2, alright. So, like it is given here, the activation energy of a chemical reaction can be rate constant two different temperatures, as I mentioned. So therefore, we take it as log K2 minus K1 equals to EA upon 2.303 R, 1 upon T1 minus 1 upon T2. How to convert ln to log to the base 10? We multiply it by a factor of 2.303. Oh, here the value will be there. So what is required? At different temperatures, different rate constant is required. Therefore, the answer would be B. In the next question, the slope of Arrhenius plot ln K versus 1 by T of a first order reaction is this. Okay. And the value of EA of the reaction is, we have to find the activation energy. This is the Arrhenius equation. Now we can do this. We have done it several times now. And what is the slope? Slope is minus EA by R. Why? Because we will fit it into the equation y equals to mx plus c. So minus E by R is the m here. X is 1 by t, y is ln k. We'll just equate and put the values. R is already given to be 8.314 joules per Kelvin per mole. Therefore, the final answer after converting it to kilojoules would be 41.5 kilojoules per mole. Now, in the next question, the order of the reaction may be negative. This is the assertion given to us. This is true. Yes, the order can be negative, zero, or fractional. Reason, in some cases, the rate of reaction decreases as the concentration of the reactant increases. This is also true. If the concentration of the reactant will increase, then the equilibrium will shift in the backward direction. That is, the rate of the reaction will decrease. Okay, so this is true, and this can be the correct explanation of the assertion, because upon increasing the reactant, our order is proceeding towards the negative side. So this is correct and the correct explanation of assertion also. In the next question, which of the following statements is are correct? For a zero order reaction, concentration R versus time gives a straight line plot. Okay, and for a first order reaction, a log R naught by R does not vary linearly with time. An inversion of cane sugar is a pseudo order reaction. See, for the zero order reaction, we have seen this many times that R equals to minus KT plus R naught. Therefore, Y equals to MX plus C. Therefore, R and it is fitting into this straight line equation. Therefore, it will be a straight line plot, although it would be in negative side. Okay. And this is what we get. This would be the intercept here. It would be the straight. I'll just make it straight. Okay. And see in second point, it varies linearly. You can see in this graph, it is a straight line that is, it is varying. So this statement is wrong. An inversion of cane sugar is a pseudo first order reaction. What is a pseudo first order reaction? That is one of the reactants is in excess. Therefore, we do not take it in the order. We do not count it in the order. Therefore, it is a pseudo first order reaction. This is also correct. Therefore, the correct answer is 1 and 3. Now, during decomposition of an activated complex, what happens during decomposition of an activated complex? Let's see. The energy, see, initially to form the transition state or the activated complex, we require energy. That is the activation energy, alright. And when it is formed and upon decomposing, energy is released to form products. Okay, so but it may be the case that all the activated complexes are not forming the product. It might revert back. As in, if we have this reaction, then this is our activated complex. Instead of going in this direction, it can also go in this direction if the barrier is less. So it may revert back to reactants. Okay, so what is the correct option? That energy is always released and reactants may be formed. This is wrong and this is also wrong. Therefore, the correct option is 1 and 4. In the next question, for a reaction A to B, the rate of the reaction quadruples when the concentration of A is doubled. What the rate expression is given to be this, and what is the value of MC? This is easy. How we'll do it? If the rate of the reaction is quadrupling, that if initially say it was this, uh, and now upon doubling A, okay, upon doubling A, that is making it 2A, what we are getting 4R. It is uh, becoming 4 times. How can it be done? So it can be done in this way. Therefore, n equals to 2. In the next question, the correct option for the redox couple is, what is the redox couple first? See, in this, one element is written and in this way, and it has oxidation state which is more and one which is less. Therefore, it can be reduced or as well as oxidized. For example, a redox couple can be this. Okay, so let's see. Both are oxidized forms involving the same element. No, both are reduced from no. One is oxidized. Both the reduced and oxidized form involve the same element. Yes. Cathode and anode together. No. So this is our correct answer. In the next question, which of the following reactants is the metal displacement reaction? See, here aluminium is also metal and Cr also, and aluminium is displacing Cr. So yes, this is the correct option. In other, this is not the case. This is the correct answer. In the next question, in which one of the following changes there are a change of 5 electrons? See, MnO4 minus 2 give Mn plus 2. See now, if we will balance it, then, or even without balancing, we just see the charge. Therefore, Mn here is in plus 7 oxidation state. So, and it is becoming plus 2. So, what is the difference? 5. Therefore, yes, this is the correct option. Now, in the next question, the decomposition of hydrogen peroxide to form water and oxygen is an example of disproportionation reaction. This is the assertion. The reason given is the oxygen of peroxide is in minus 1 oxidation state and it is converted to 0 in O2 and minus 2 in H2. Let's see. See, this is the composition of H2O2. From minus 1, it is going to minus 0. One is oxidizing and another one is reducing. Therefore, it is an example of disproportionation reaction. Assertion is correct. And the reason is also correct because converted to 0 and minus 2. So both are correct and it is the correct explanation. In the next question, identify which of the following reactions is our combustion reaction. Okay, so in a combustion reaction, as I mentioned earlier, the element will be combining with oxygen. Okay, so in this case it is true and in this case, therefore A and C is the answer. Let's see the last question. In the reaction I2XS, see this is the reaction given. I2 is initially in 0 oxidation state and here it would be in minus 1 oxidation state. Okay, so it is being reduced. It is gaining electron from 0 to minus 1. Okay, so if it is reducing, then therefore it will act as an oxidizing agent. Species itself getting reduced and oxidizing the other species. So this is the correct answer. So that's all for today. We will be meeting in the next video with other sets of questions. Thank you.